Problems about the discriminant are very common. So let's have a look at some. We're given that x squared plus 8kx plus k is equal to 0 has equal roots, and we want to find the value of k. So let's think about this. So we've got equal roots. We know that that means that the discriminant must be equal to 0. Now here we have a is equal to 1, b, remember that's the coefficient of x, so that's equal to 8k, and c is k. So the discriminant is going to be equal to 8k all squared, take away 4 multiplied by 1 multiplied by k. Remember, both of these things need to be squared, so that's 64k squared. Take away 4k, and what we're being told is that 64k squared minus 4k is equal to 0. Note that I lost this equal sign here. So that's because of the equal roots, as we mentioned in the first line. We can take out a common 4k here, and we'll be left with 16k take away 1. And we've done a lot of solving quadratics, so that gives us 4k equals 0, or 16k take away 1 is equal to 0. This first one gives me k equals 0, and this one gives me that k is 1/16. The equation k plus 3x squared plus 6x plus k equals 0 has two real distinct roots. Find the possible values of k. So if we have two real distinct, we know that that implies that the discriminant is positive. Here we can see that a is equal to k plus 3, b is equal to 6, and c is equal to k. So delta is going to be 6 squared take away 4 multiplied by k plus 3 multiplied by k, which is 36 take away 4 lots of k squared plus 3k. So that's 36 take away 12k take away 4k squared. So we're after 36 minus 12k minus 4k squared is greater than 0. Now we can take out a 4 here, so divide through by 4. We're okay to do that. We're dividing through an inequality by a positive number, which is fine. So that's 9 minus 3k minus k squared is greater than 0. And I always like my k squareds, or my squared term, to be positive. So I'm going to move everything to the other side of the inequality. And that would give me a positive k squared, positive 3k. Of course, the 9 would become negative because I've subtracted it from both sides. And everything's over this side now. So I have to make sure the right side of the inequality faces it. So what we're going to do is solve this. So I'm going to start by considering k squared plus 3k take away 9 is equal to 0. Now I don't need to look at this very long to see that I can't just do this by factorizing. I can't spot two numbers that multiply to give me -9 and add to give me 3. So I might need to apply the formula to this. Well, to do that, A is 1, B is 3, C is -9. So it's not X this time, of course, it's K. So that's going to be -3 plus or minus the square root of 3 squared, which is 9, take away 4 multiplied by 1 multiplied by -9, all divided by 2 lots of 1. So that's -3 plus or minus the square root of 9 plus 36. So that's 45, all divided by 2. So it gives me two solutions. -3, add root 45 over 2, and -3, take away root 45 over 2. And the reason I didn't write that in on the first one is because we can think about surds. Square root of 45 is the square root of 9 times 5, which is the square root of 9 times the square root of 5, so we can write that as 3 root 5. Now, if we were to graph y equals k squared plus 3k minus 9, because the k squared term is positive, we have a happy curve. These solutions tell us that it would cross the k-axis at -3 add 3 root 5 over 2, and -3 take away 3 root 5 over 2. So it would look something like this. And we're after where it's less than 0, i.e. below the axis. And we can see that happens between these two values. So therefore k must be more than -3 take 3 root 5 over 2, which is clearly the left hand of these roots, and -3 plus 3 root 5 over 2, which is the right hand of the roots. So that was a fairly complicated example, but this is the level you're working at now.